Hello everyone. Previously we had discussed on the topic graph, right? So today we'll be discussing on the topic tree, right? Let's get into the definition part here. What does the definition part of the tree say here? A tree is a hierarchical data structure with a node, root node and child nodes forming a parent-child relationship, right? So this is the simple definition part, right? A tree is a hierarchical data structure with a root node and child nodes forming a child parent-child relationship, right? So just for the simple example, let me consider here this one, right? So this one consisting of 1 here, so this one consisting of 2, the value 2, and this one 3, right? So this is nothing but the root node, this is nothing but the root node, right? So these are its children. Basically this is the child node or the leaf node, right? So these 2 and 3, these are the children of 1, and this is the root node, the first node, right? So this is the root node and these are its children, this is leaf node, again the value 2 and 3, these are its children as well, right? So this is the simple example for the tree, right? So let me go with the next point, which is important. Trees are used for hierarchical data representation, searching and sorting, right? So for the simple example, I have considered binary search trees, right? So searching I have given here, so we'll be going with a binary, we can go with a binary search tree as well. So here trees are basically trees are useful or used for hierarchical data representation here, especially for searching and sorting as well, right? So example, binary search tree I have given. So here there are different type of trees, man. Binary trees, binary search tree, and there is something called balanced binary tree as well, and balanced binary search tree as well, right? So there are AVL trees, right? So there are AVL trees, and this one heap is showed in the tree structure as well. Heaps are showed in the tree structure as well. Max heap and the minimum heap, they are showed in the tree structures, right? So just keep this in mind. There are different type of trees, so I can just go through any trace. I'll just tell you the most important ones that are used are this one, binary trees and the binary index tree, binary search tree, right? So these two things you have to know at any cost, right? So binary search tree is something, I'll just give you a very simple example. Basically binary trees means, so here we have two values, right? So two trees, so this one, right? So this is something we call it as binary trees, right? So what is difference between the binary trees and the binary search trees? Basically, so here suppose I have one here, so the value of the left node has to be always smaller, right? So I can just give here 0, this one 0, right? So this one, the right child value has to be always greater than the root node. So this one has to be this one, sorry, just give me a second, man, here. So yeah, me show this one 1, so this one 0, and this one 3, right? So this one has to be always smaller, the left child value has to be always smaller than the root node, and the right child, this one value has to be always greater than the root node. So this is binary search tree, right? So this is the binary search tree condition, basically criteria to be the binary search tree. And there is something called balanced binary tree, where every level has to consist of the two children, right? Every level must contain two children, right? Two subchildren means root, this has two. If we have one more level, then if it has to be balanced binary tree, then we have to be go with same thing here. One value, this has to contain one value, and this one has to be two values as well, right? So every level, this one or every node must contain two subchildren equally, right? So that is said to be balanced binary search tree. So now we know the difference between the binary tree and the binary search tree as well, right? So you can just go, there are different trees, there are AVL trees, you can just go through it. So these are very common ones that I said, right? So this one usually will be solving the problems. We have solved a number of problems on binary tree and binary search tree as well, right? So we have finished that one in the Java. So I just wanted to say the same here, right? So we are done with the definition part as well as the important points, and we saw what are trees, right? So now let me give you a very simple example, man, right? So one thing I want to tell you here is, so see here, A tree is hierarchical structure with a root node and child nodes with no cycles, right? And one more thing here, so binary trees have at most two children per node. I have said this one, right? At most it can consist only two children, not more than two. Binary trees, even with the binary search trees, right? So at most it can have two, right? Binary trees have at most two children per node, not more than two. So there are AVL trees, and max heap and the min heap is also represented in the tree format itself, right? So now let's see the same thing with very simple example, man. So let me consider very simple example here. Let me go with class node here. Let me go with a class node here. So let's go with the initialization part first. So I'll just go with def init, right? So nothing but the initialization part. So let me remove this one. I'll just consider self. Uh, so let me go with value as well, man, along with the self the parameter. So I'll just go with a value. So I'll just give here self dot value. Let me assign this one to the value. This is fine. Now I'll just go with self dot children. Let me give simple this one array, right? Empty array. So this is fine. Now let's do one thing. Let's create root and children, right? So let's create root and children. So I'll just assign root to node of this one, root, node of root. This is fine. Now let me go with the child one here. So we will be going with the two child nodes here. Child one, let me go with node of I'll just give child one itself, right? So within the string. So let me go with child two as well. So I'll just call this one child two instead of the child one. So let me go with node of, let me pass child 2 here. This is fine. So what we have done here, we have created root and the children. First one is the root, nothing but the we are just passing root. For the two children, I have passed child 1 and child 2, right? So which is the child nodes of the root basically, right? So next let's move on with the uh, further things. Let's do one thing. Let's add the children to the root. So I can just add the children to the root in this way. I'll just go with the root dot children. So I'll just go with the append keyword here, right? Append. So let me append the child one here, right? So the same thing I'll be doing next. So instead of the child one, I'll just append child two here, right? So this is fine. We are done with the coding part almost. So we have to display the tree structure. So let me go with the print here for the interactiveness. I'll just go with the root dot value, right? So root dot value. So let me go with the simple for loop here for child, individual child, and root dot children. So let me go with print here, print. So this one is fine. uh, let me give arrow mark so that we can see that one clearly. So let me give comma here. I'll just pass the value of the child, nothing but child dot value, right? Child dot value. So what is the output that we need to get here? Root along with child 1 and child 2, right? Root first one, child 1 and child 2 with this symbol, right? So we have passed the symbol via this one within the strings actually. Let's see what output that we get here. I'll just go with a Python. So let me come here, let me copy the file name, paste it dot py, right? So see here we are getting the root first, and for this root this has two children, nothing but child 1 and child 2. We are getting the output that we are getting is absolutely correct, right? So we are getting the desired output. Basically this shows the root node and its two child nodes. This shows the root node and its two child nodes, right? So this is it for the tree. Very simple, man. A tree is nothing but, again, a tree is nothing but hierarchical data structure with a root node and child nodes forming a parent-child relationship. Trees are used for hierarchical data representation, sorting, as well as sorting as well as searching, right? A simple example I have considered here, binary search tree. I have showed the binary tree and the binary search tree. And also one more, the main point I have said that binary trees can have at most two nodes, not more than that, right? That's very important. Just keep that in mind as well. And I have shown you the binary search tree as well, right? So just keep that in mind as well, right? So what is the criteria to be the binary search tree? So it will be helpful, man. So I just wanted to stress on that, right? So we have got the correct output, right? So we are done with the trees, right? So we are done with the tree. Simple, right? So let me summarize whatever we have learned so far. Trees are the backbone of many algorithms. Just remember this one. Trees are the backbone of many algorithms, organizing the data in structured hierarchy. Organizing the data in a structured hierarchy, right? So we are done with the tree part. We are done with the tree part. Next, what we're gonna do next? So we will be discussing on the topic try. There is a topic called try, right? So uh, we'll be discussing on the try, right? So for now, this is it. Thanks for watching, guys.